Hello my dear students, welcome back to NEET WORLD. So we are discussing hydrocarbons for our upcoming EAPCET 2026 and 2027 right now. So these sessions are also helpful for your NEET and JEE preparation. Okay, so in the last session we have covered up to chemical properties of alkenes right now. So where we have discussed addition reactions and we have started discussing about oxidation reactions also right now. So today we will be discussing this oxidation reactions, then other reactions like substitution and other polymerization and isomerization reaction. So if you want to look at the PYQs of this particular chapter, from this particular chapter and these topics, just look at here how they are asking questions here. See this kind of questions you can see in the exam. See they are treating this with ozone. Upon ozonolysis of this alkene, what is the product formed here? Or see here this kind of question. So which of this alcohol will be react faster when we treat with H plus ion, like dehydration will be possible in which case? Okay, again see this one, upon ozonolysis what will be the product? See ozonolysis question is one of the more and more important question, like it will be repeatedly asked, see multiple times this particular type of question. And see this one also again ozonolysis based question. So how many, like see what type of what will be the reactivity of given alkene with acids like HX type, like HCl, HBr or HI is given. So which is more reactive and how it will react, what type of mechanism it will follows. So those kind of reactions will be appeared in the exam. Okay, right. See this one again, see they are treating an unsaturated organic compound X with hot acidified KMnO4. So what will be the reactant that gives this succinic acid out of this food? Very easy. So once after a discussion, once after completing this discussion, you are going to solve all these questions without any confusions. Okay, so just patiently listen this session till the end. Definitely you are going to answer all these kind of questions. Okay, so let us start our discussion on chemical properties, especially oxidation reactions now. Okay, so first one here I am taking oxidation of alkenes. The first reaction here I am considering is ozonolysis reaction. Ozonolysis reaction. Okay, so this is very simple and very easy to remember. I will tell you how can you identify product just by looking at the reactant. See, first of all take one alkene. Okay, so I am considering alkene here, CH2 double bond C, CH3, CH3, like this I am taking. So now just look at here what happens when we do this ozonolysis. So take the alkene, treat this with ozone. Okay, ozone means O3 in presence of some reducing agent like zinc or like dimethyl sulfide, like that you can consider. Okay, now what happens is, so this ozone will gives oxygen atoms that will be added to these carbon atoms, that's it. Okay, so what is a simple way to remember here is to identify the product is just this double bond is there now, break the double bond and insert oxygen on both carbons like this, and you can insert this side also plus CH3 H double bond O. So these are the two possible products whenever an alkene is given. So alkenes upon ozonolysis gives carbonyl compounds, aldehydes or ketones. Okay, so remember here what you are seeing. So one side we have CH3 na. So wherever we have internal alkene, that is carbon is not a terminal, carbon is having some alkyl groups, means you should not say it as a terminal, but this carbon you can consider it as a terminal, like because this carbon is a last carbon. After this carbon we have only hydrogens, no carbon. So you can consider this carbon as a terminal carbon. So these terminal carbons containing alkene gives aldehyde, and with our internal alkene carbon will convert into ketone like that. Okay, so these are the two things to be remembered. Two things to be remembered while you are doing this ozonolysis type of reactions. Okay, let me adjust this screen. Yeah, so now tell me here what will be the product what will be the product? I am taking it like this, I am adding one double like methyl group here. So upon ozonolysis what happens, tell me, upon ozonolysis what happens? So what I told you, just break it like this, okay. So on this carbon we have one hydrogen and one methyl group now. So you can write this as CH, this side CH3 and here double bond O, that's it, that's it. So what about this? These are dimethyl groups now. So carbon with two methyl groups and here it is having double bond now. So insert the double bond with one oxygen, that's it. So wherever double bond is there, just break it and insert oxygens. Out of this ozone 3 oxygens, we have given one oxygen this side, another oxygen this side, one more is left now. So that will be treated with this zinc and it will converting zinc to zinc oxide, okay. So this is a reducing agent. If we are not using this reducing agent, okay, so now this alkene that gives aldehyde now, that aldehyde further undergoes oxidation to give carboxylic acid, so that we can call it as oxidative ozonolysis, okay. So now I will show you one example of oxidative ozonolysis. So same substrate I am treating with ozone and along with this I have H2O2 like hydrogen peroxide, which is oxidizing agent now. So that will faster the reaction, this oxidative ozonolysis reaction, this is oxidative ozonolysis reaction. So what happens is, wherever we have hydrogen atom attached to this double bonded carbon now, that will also converts into OH group. It means it will be oxidized. See what I am writing here, C double bond O. If there is directly attached methyl group now, do not disturb it, you just keep it as it is. But this side directly attached hydrogen is there now, it will converts into OH group, that is carboxylic acid is formed this side. Whereas this side if you observe, you have only two alkyl group, CH3 and here also CH3. Now here you have double bond O, that's it. So ketones will not be get oxidized with oxidative ozonolysis, but if we have aldehyde kind of product, that will be oxidizes to carboxylic acid when we are using this oxidative ozonolysis reaction, okay. So it means terminal alkenes will be converted into carboxylic acid, whereas internal alkenes like this will be converted into ketone, okay. Remember this statement to answer it properly, okay, right. So now I will show you one reaction here. So how the question will be made during the exam means, just they will give one alkene here, okay, they will give one alkene here, okay. So to this they will say ozonolysis in presence of zinc, that gives A, this A upon treating with dilute NaOH and upon heating gives B. So they are asked what is this A and B during the reaction. So here if you observe what is the steps involved here, ozonolysis now. So ozonolysis in presence of zinc means definitely carbonyl groups like aldehydes or ketones are formed. So if you break this double bond, you will get dimethyl ketone, that is acetone you will be getting. And what about this? This will be giving CH double bond O, formaldehyde is formed. So these are the things formed as A here, okay. Now these treated with dilute NaOH. Dilute NaOH is a base now. So now this base subtract a acidic proton. Do we have any acidic proton here? Not in this formaldehyde, but in this acetone we have, because these alpha hydrogens are acidic, okay. So now you can say this will undergo aldol condensation. What happens? So this will undergo aldol condensation to give this product B. So you can expect a cross aldol product, like this is providing alpha hydrogen, and that after removing we will get a negative charge on this carbon that will attacks here and gives a cross aldol product. So what is a cross aldol product formed here? So just take this CH3, C double bond O, this is CH. So this base will abstract this proton. So if you do not knowing about this aldol condensation reaction, you just search aldol condensation reaction in this playlist only, it will be there. Already we have discussed some named reactions. You need to go through all those named reactions, okay. So this base abstract a proton from this alpha hydrogen of carbonyl group and creates a negative charge. That negative charge will be added here, so that it will convert into alcohol now, okay. So CH2 OH, okay, like this it will be forming. So this is alpha beta. So what we got? Beta hydroxy ketones we got now. So this upon heating, this OH group from here and hydrogen from here are removed as water, like dehydration takes place, and that gives alpha beta unsaturated carbonyl compounds. What it will be giving? Alpha beta unsaturated, like alpha beta unsaturated carbonyl compounds are produced during this reaction. So this is our product B during this process. Okay, so this is how you need to do the chemical reaction. Okay, hope the discussion is clear here. which is stronger acid out of this 4? If I consider this many groups like HF, HCl, HBr and HF, HI, so which is stronger acid out of this 4? So how can you say this? So HI will be stronger acid, then HBr, then HCl. So if you consider like this, so which is stronger? HI. After that HBr. So who will give H plus ion readily? HCl or HBr? HBr will be giving H plus ion readily now. So since it is a stronger acid, releases H plus ion. So now this H plus ion is taken by this double bond of this alkene. Okay. So this will be accepting this H plus ion. Okay. When it is accepting, you will get a H here and positive charge on this carbon. Next, what happens here? Bromide ion is there now. So this bromide ion will be added on this carbocation and that gives you Br. So this is your final product. This is your final product. Okay, right. Similarly, if I take here HBr, tell me what will be the product formed in the reaction? What will be the product formed during this reaction? See, again HBr releases H plus ion. So this H plus ion is added to either any of these carbons. Okay. So now if I add on this carbon, you will get a positive charge here. Okay. Or if I add H plus on this carbon, you will get a positive charge here. If I add H plus ion here, you will get positive charge here. But which carbocation is more stable? The carbocation which is at this benzylic carbon is more stable because it will be in conjugation with the ring pi electrons. So you add H plus ion to this carbon and generate carbocation here. Add H plus here, generate carbocation here. So to this we can add our Br minus like this and gives a final product Br. So this will be your final answer for the reaction. Okay. So now based on this now I will be giving you one simple statement here. So whenever, if you observe both of this reaction, these are both of them are unsymmetrical only. So whenever we are adding an unsymmetrical reagent, what I am saying, unsymmetrical reagent like HX, unsymmetrical reagent like HX. So the negative part of this adding molecule, we can say addendum, negative part of addendum means adding molecule, addendum goes to more number of hydrogen atoms containing carbon atom. Okay, see here you have 2 hydrogen atoms, here only 1 hydrogen atom. Where do we have more number of hydrogens? Here now. So that's why, see what more number of, less number of hydrogens goes to less number of hydrogen containing carbon. See here you have 2 hydrogens, here 1 hydrogen. So negative part will goes to less number of hydrogen containing carbon and hydrogen goes to more number of hydrogen containing carbon. So this is called Markovnikov rule. See, it is not about remembering the statement, just try to understand where will be the carbocation will be more stable. So here it is secondary. If I generate carbocation, here primary. So secondary carbocation is more stable now. So generate a secondary carbocation whenever you are adding. Okay, it means more stable carbocation should be generated. See, here also you can generate carbocation and here also you can generate carbocation by adding H plus ion. But at which position it is more stable? Benzylic carbocation is more stable now. So that's why generate a positive charge on this more benzylic carbon, not on this this side carbon. Okay, by adding H plus on the other side. Okay, so Markovnikov's rule. Okay, so what this Markovnikov's rule says, unsymmetrical reagent, whenever we are adding unsymmetrical reagent, negative part of this unsymmetrical reagent, that is addendum, goes to less number of hydrogens containing carbon. It means, this is the example you can understand. So this is called Markovnikov rule, and there is one more called Anti-Markovnikov rule, that is like opposite of this. It means negative part will be goes to the more number of hydrogen containing carbon. That is what Anti-Markovnikov rule. Okay. So now you got two rules. One is Markovnikov rule, Anti-Markovnikov rule. Those are nothing but I am adding HBr to this. Where do you add this H plus and Br minus? Tell me. See, H plus will goes to a carbon which is having more number of hydrogens, and negative part bromide ion goes to less number of hydrogen containing carbon. Okay. So it means here bromine, here CH3. This new hydrogen is over here only. Okay. And if I do the same reaction, sorry, the same reaction, HBr, addition of HBr in peroxide presence, like H2O2, R2O2, some peroxy bond will be present here. So now what happens here is the addition will be reversed because it will follow free radical addition reaction. Okay, it means reverse means what? Opposite means what? You add hydrogen here, bromine here. That's it. Okay, this is Anti-Markovnikov rule, Markovnikov rule addition. This is Markovnikov rule addition. Okay, that's it. Okay, so what is the use of remembering the two statements? See, in hydroboration reaction, like B2H6 we discussed it now. So where this H plus and Br minus go H and OH goes, because hydroboration of alkenes with H2O2 and NaOH gives alcohol, we know. So it means we need to add H and OH from this thing. So where H and OH goes, so I told you it follows Anti-Markovnikov rule. So this negative part if you consider, this is positive part if you consider, so negative part goes to this terminal side and positive part goes to this internal side. Okay. So now tell me here, so you need to add B2H6 and H2O2 NaOH. So what will be the product formed? What type of product it will be giving? Tell me. What type of product it will be giving? Tell me. So very easy. You need to add H plus and OH minus. So where H plus and OH minus goes on this? See, wherever we have more number of hydrogens. Okay. So Anti-Markovnikov rule now. So wherever we have more number of hydrogen, there you add negative part. What is the negative part here? OH minus. Okay, that's it. So here you add OH, here you add H plus. This is Anti-Markovnikov rule type product. Okay. So both whatever the groups we are adding, H and OH we are adding now, so these should be in same plane. Syn addition should be taken here. Syn addition is taking place. It means the newly incoming groups like H and OH should be in same plane. Both of them are like above the plane, or both of them are should be below the plane. Okay, like this. Above the plane or below the plane. Remember these two statements. Okay, right. And the next thing is oxymercuration, demercuration. What do we mean by oxymercuration, demercuration? See, same unsymmetrical alkene will be there. To this, we need to add, let us say I am adding water. Okay, so I am adding water. Okay, so this happens in presence of mercuric acetate. Mercuric acetate means I am writing HgOAc twice. Okay, and after this I am using NaBH4. This NaBH4 is a demercurating agent. See, oxymercuration, it means we are mercurating first to this alkene, then we are demercurating it. So for this demercuration purpose, I am using NaBH4 as a demercurating agent. Okay, demercurating agent. Okay, so now what happens here is, first of all, this Hg will make a 3-membered cyclic ring. Okay, so that, see, directly product I will tell you here. See, what is the Markovnikov rule means? Just simple. To this we need to add water in presence of this thing. Okay, that's it. It means you are going to add H and OH. Okay, this OH is coming from water and H is coming from this NaBH4. Remember that. Okay, so where this OH goes, where this H comes, tell me. So it simply follows Markovnikov rule addition. What it will follows? Markovnikov rule addition. It means, what do we mean by Markovnikov rule? So what is the negative part? OH minus. So this OH minus will goes to this carbon, like more number of like more stable carbocation, and hydrogen goes here. So you can add OH here and hydrogen here like this. Okay, so there is no rearrangement in hydroboration reaction as well as in this OM-DM reaction also. Okay, so first this HgOAC, like acetate ions, these are acetates, okay, will form a 3-member cyclic ring here, HgOAC, okay, with positive charge. To this, our water molecule will act as a nucleophile. So here it will be ring opening taking place, because here it will be more stable carbocation, that's why. Okay, so, and gives us OH, and this side HgOAC. Okay, like this it will be formed, and after this we need to remove this HgOAC. For that I am using NaBH4. So this NaBH4 is a demercurating agent and gives us this product. Okay, that's it. Okay, just tell me here. Just tell me here. So what is the product form? Tell me here. So just write this as it is, and here it will form a 3-member ring, like cyclic ring with mercury, and after that H2O will attacks here, and hydrogen here comes from this NaBH4. This is what the product form. So there is no rearrangement, nothing. Whatever the position the double bond is there, that will be reactive site. Okay, so here if I write like this, so if I wanted to make a few reactions, for example, I am adding HBr, I am doing same for the same alkene, I am adding H2 B2H6 and NaOH H2O2 mixture I am adding, and third reaction here I am giving you is OM-DM. OM-DM means what? Oxymercuration, demercuration, DM reaction. Okay, and yeah, so tell me what happens here, what happens in 3 cases, tell me here. Very easy, wherever we have double bond, the reactivity site is there. Okay, but when we are adding HBr, there will be rearrangement. Why there will be rearrangement? Because H plus ion will attacks on this first and generates a carbocation here, that is a secondary carbocation. Now hydride ion from here will be shifting from there to here, and here we will be getting a tertiary carbocation. See what I am saying here is, to this add HBr, from that HBr you are first adding H plus ion. So this alkene will take and gives a positive charge on this carbon, and you have hydrogen here will migrate onto this secondary carbon. Why will it migrate? Because secondary carbocation is less stable now. So if this hydride ion is shifting, you can generate a tertiary. Okay, like this tertiary you got. To this we need to add bromide ion. Like this. So this will be the product in the first case. And what will the product in the second case? Tell me. Hydroboration in presence of H2O2 and NaOH means alcohols will be the product. So there is no rearrangement, nothing when you are doing hydroboration and OM-DM reactions, because it follows cyclic transition mechanism. So in this case you will get a 4-member cyclic transition state. It means it's a concerted single step reaction which is a syn addition. Okay, it means wherever you have double bond, there you can add one H and OH. So OH on this terminal, H here, and what about this? OH here and H here. By looking at these 2 reactions, you should get one idea that if you want to create OH group on terminal side, you need to use hydroboration reaction, and if you want to get your OH group internal without any rearrangement, you should use OM-DM reaction. And if you want to make your OH group at this tertiary carbon, you simply use hydration. It means addition of water molecule in acidic medium. What happens in acidic medium now? First H plus ion attacks here, so that it will be generating a carbocation on this secondary carbon. Okay, now this secondary carbon will undergo rearrangement by this hydrate shift, and this will be giving you a tertiary carbocation. So to this now you can add our water molecule as a nucleophile here and gives a final product like this. Okay, so now you got 3 reactions, like 3 ways to make your alcoholic product. First way is to hydroboration, that gives at this terminal like terminal position carbon OH group is added. It means this is a terminal hydroxy group is present, so that is what hydroboration helps us. And OMDM gives secondary alcohol, and if you want to prepare this tertiary alcohol from this alkene only, so just follow this rearrangement mechanism and gives the final tertiary alcohol. So these are the 3 ways to prepare primary, secondary, tertiary alcohol from the from our starting material alkene here by rearrangement reactions and all. Okay, hope this discussion is clear. And next one, I will tell you some simple ways to remember some reaction. See, whenever there is alkene, okay, so now they will say us to treat this with Bayer's reagent, Bayer's reagent. So they may also give instead Bayer's reagent, they will give, it's a dilute cold KMnO4 or dilute KMnO4 or cold dilute KMnO4, like that they will say. Okay, so this one, whenever you are seeing this, simply remove this double bond and insert 2 OH groups. Wherever double bond alkenes are there, carbons are there, you insert just 2 OH group. So you can simply say it is a dihydroxylating agent. It means 2 position, it is hydroxylating now, so dihydroxylating agent. Same story happens with osmium tetroxide also, Now instead if I use concentrated KMnO4, concentrated means here it will be concentrated KMnO4, instead they will be mentioning it as hot KMnO4. Other ways, same thing may also given H plus ion acidic medium KMnO4. If they mention it like this, so what to do is just follow this simple trick. Break this double bond like this. Wherever we have double bonds, now break that carbon-carbon double bond, and here you have one carbon, here you have one carbon, right? So this carbon also contain one methyl group, one hydrogen now. So here see what I am writing. This is a carbon having one methyl group this side, and this is a double bond now. So insert double bond like this, and here one hydrogen is there now. Convert it as into OH group. Okay, and this side double bond we have, break it and insert one O. Okay, this side you tell me what happened. Same carbon you write, this double bond side insert one oxygen. Okay, this is a simple way to understand the concept, that's why I am giving these steps. And how many hydrogens are there directly attached? 2 hydrogens now, so write them as OH groups, OH. Okay, from this is a carbonic acid. From this water elimination takes place like this and gives CO2 gas plus H2. Okay, so what to do whenever there is alkene with hot KMnO4, acidic medium KMnO4, just break the double bond. See, it means complete oxidation is taking place. So wherever there is directly attached hydrogen to the double bonded carbon, convert it into OH group, and if there is any methyl group, write as it is. If there is any double bond, insert O by breaking them into equal halves. It means, tell me your answer for this question. This alkene is there like this, so how can you break this with hot KMnO4? Hot KMnO4, what you will be doing here? Hot KMnO4 means just break this double bond in this way. Okay, so after breaking, okay, insert one oxygen both sides, and if there is any directly attached hydrogen to the double bonded carbon, write it as OH group. Okay, that's it. This kind of product from this side. What about this side product? It will be this side now. So there is no directly attached hydrogen to convert into OH group. So write these groups as it is. Yes, written as it is, and this one as C double bond O. That's it. So these are the 2 possible products from this hot KMnO4 using this alkene. Okay, so these are the reactions you should remember here, and along with this, just look at this reaction. These are for your reference. I am giving this. Okay, just go through all this reaction. Whatever we discussed till now, they will be included in this one single sheet. So make a list of it. And the next ozonolysis we discussed. Yeah, look at this. KMnO4 is given here. So whenever there is KMnO4, what happens? It will oxidizes. Generally alkanes does not react, but isopentane contain a tertiary hydrogen. Okay, isopentane contain a tertiary hydrogen here. So that tertiary hydrogen, this tertiary hydrogen will be converted into alcohol with this KMnO4. It means this OH group is formed. So this OH group containing alcohol formed as X upon dehydration. So dehydration means you have protons here now. So remove this hydroxy group and you will get an alkene like this. So first option is perfectly correct for this question. Okay, and the next. This is a question which I have already discussed. Ozonolysis of this gives ketone. So I have explained this reaction. Just go through the discussion and tell me your answer for this question once again. If you have followed the session, you can easily answer because exactly same question I have explained. Now I am giving the same question as your homework. So just tell me your answer for this particular question in the comment box. Okay, right. So first one is ozonolysis step gives X and Y as a product. So this XY treating with dilute NaOH and heating, this is aldol condensation now. So that product will be formed as X. So tell me what is Z, which is a product in this reaction. So give me your answer in the comment box. If you are not knowing, just go through this video itself. At the discussion of ozonolysis, I have explained this example itself. Okay, right. Next. These are also for your reference. I mean, just take a screenshot and go through them, like what happens in addition reactions. Like these are addition reactions I am showing, and these are also addition reaction, but here it is Markovnikov rule with a rearrangement reaction, if any possible, and hydroboration and oxymercuration, demercuration, rearrangement, no rearrangement in these two cases. Here it will be rearrangement. We discussed all these things, right? So now this table is again important. Bayer's reagent will be having purple color. What is the color? Purple color. So this purple color or pink color upon adding to this alkenes will get disappear. Pink color or purple color of KMnO4 get disappear when we are adding to this alkene. Okay, because it will be giving this dihydroxy groups now. So during this, the KMnO4 +7 oxidation state will be reduced. Okay, due to that reason it will be decolorized. Okay, so we can say by looking at the color change, yes, the given compound is unsaturated compound. So now we can distinguish alkanes and alkenes using KMnO4, because alkanes does not react with KMnO4 but alkenes react. Okay, right. So next, bromine water also react with alkenes only, not with alkynes. Alkenes, okay, does not react with alkanes. It will react with unsaturated compounds like alkenes and alkynes. Okay, so this red color will decolorized when we add, say, bromine will be having reddish brown. So this reddish brown color will be disappeared when we treat this with an alkene. Okay, again ozonolysis will give carbonyl compounds as a product. So this will be, ozonolysis will be useful for identification degree of unsaturation in the given organic alkene compounds. Okay, alkenes or alkynes also. Okay, that's it. This is the acidic nature. So which is more acidic? Alkynes are more acidic than alkenes, than alkenes. Okay, so alkynes, because sp hybridized carbons are there now. Yes, this is an alkene. Yes, this is more acidic. And here you have an electron releasing group. In organic compounds, if an electron releasing group is there, their acidic nature decreases. That's why simple alkane is more acidic than this alkyl group containing alkane. After that, alkanes are more acidic, then next alkenes, and least is for alkanes. So first option is perfectly correct. Okay, next. The alkane that gives only monochloro product and chlorination with Cl2 in presence of diffused sunlight. Okay, what they are saying, an alkane that gives only one monochloro product. Okay, so it means you just write the structures. You just write the structures. Dimethyl 2, 2, 2 dimethyl butane. So first of all write butane, this is 2, 2 dimethyl butane. Okay, so what they are saying, an alkene that on monochloro product and chlorination only gives monochloro, one monochloro product. It means if all the hydrogens are same on the given compound, it will be giving monochloro, only one type of product. See, but here you have these 3 hydrogens are of one type, and here this is second type. So it means this is third type. It means you are going to get 3 types of monochloro products, 3 types of monochloro products. So how can you identify these? Just identify number of types of hydrogens present. Okay, if I say neopentane, how do you write the structure of neopentane? So this is the structure of neopentane. Just check how many carbons are there. 1, 2, 3, 4, 5. Okay, 5 carbons are there, but there is no hydrogen here. Only this methyl group hydrogens are there in all these carbons, right now. So it means all these terminal hydrogens are same now. Yes, all these 4 are same. It means you are going to replacing one of this hydrogen with this chlorine, right now. So monochloro product will be formed here. That will be same whether you substitute any of this hydrogen, that will be giving only one type of product. Okay, so one type of product will be formed like this, okay, in all the cases. So what is the answer for this? A neopentane will be your answer for this question. Okay, that's it. Next, okay, we discussed about alkynes converting into cis alkenes. For this we require Lindlar's catalyst, that is H2PDC quinoline. Okay, and today I have shown you some questions. Okay, and tell me the answers for those. First of all, look at this. Given alkene is treated with hot KMnO4 or KMnO4 in acidic medium. What I told you, just break this double bond. If there is any directly attached hydrogen, converts into OH. So it means you are going to get a carboxylic acid of this third option. Okay. Look at these questions. Tell me your answers for them. What is your answers for these? See, you have halide treating with halide treated with magnesium. What happens? It will be converting into magnesium bromide. This magnesium bromide treated with D2O. So D2O is nothing but like a H2O only. Okay, in the place of H plus, here it will release as D plus. So if magnesium attached to this carbon, we know magnesium will be +2 charge and our carbon here is -1. Right now, and this bromide is -1. So our carbon can act as a nucleophile, or it will be like a strong base also. Now from these it will be releasing D plus ion now. So D plus ion will be taken by this carbon and will be giving a cyclohexene with deuterium on that carbon. Okay, so your answer will be like this. Okay, this will be your answer. So where do we have that kind of option here? Yes, option D will be your answer for the question, not any of the other. Okay, so simple, magnesium treat with alkyl halides and gives magnesium bromides, like we can say alkyl magnesium bromides. Those are nothing but Grignard reagents. Grignard reagents upon adding water gives respect to alkane. So instead of water, here we have D2O. So D2O produces H plus ion like D plus ion na. So this D plus ion will be added here, gives respect to deuteroalkane like this. Okay, deuteroalkane is here. So that will be your answer for the reaction question. Okay, next. Look at this, very interesting it is. Read the question once, read the question, read the question. Read the question and give me your answer for this. An unsaturated organic compound X on reaction with acidified KMnO4 gives a succinic acid. What is that X? So these are unsaturated hydrocarbons, organic compound that should give a succinic acid. What is the formula of succinic acid first of all? So just remember here, formula is CH2, COOH, COOH. So this is a succinic acid. So it will be formed upon treating with hot KMnO4, hot acidified KMnO4 they are saying. Hot KMnO4 with this H plus ion. Hot KMnO4 and H plus ion is mentioned here. Okay, now tell me what is our X here? That X should give this succinic acid. See, we know carboxylic acids can be formed from alkenes when we treat this with like this hot KMnO4 by oxidation reaction. So if I take cyclopentene, so it will be like this. Cyclopentene means if you break this double bond, so you are going to get 1, 2, 3, 4, 5 carbons. But our material, our product should be having only 4 carbons only. So it means this is not the one. And what about this? Cyclopropene, 3 carbons only, not the one. So between this C and D, your answer will be there. Again, if you take this 2-butene, how do you write the structure? 2-butene means like this. So if I am treating with hot KMnO4, you need to break this double bond into equal halves and that will be producing carboxylic acid, that is acetic acid is produced this side and that side. So 2 moles of acetic acid is produced, but what we required succinic acid, no? So it means this is also not the answer. Okay, so we have only option C possible here. So take the cyclobutane here. Yes, cyclobutane is taken here, so hydrogen here and here. So just break this double bond and insert 2 oxygen atoms there. So if you insert 2 oxygen atoms, here, inserted above and below, and directly attached hydrogen will also get oxidized to OH. Yes, see, yes, whatever the product we required, yes, that is the product formed here during the treatment of this cyclobutene with hot KMnO4 in acidic medium. So what is our suitable answer for this? Option C, that is cyclobutene will be your answer for the question. So option C will be your answer. Yes guys, if the thing is clear, just click on the like button. Next, what is the correct reactivity order of hydrogen halides with this propene? So tell me which is more reactive out of these halides given, hydrogen halides. So we just now discussed, like down the group acidic nature increases, therefore HI will be more acidic, it means H plus ion comes out easily. So it means that will be more reactive with this propene, with this alkene. So whoever gives H plus ion readily, that will react here, it means HI, next HBr and next HCl. So what is our answer here? So HI, HBr, HCl, C option will be your correct for this question. Next, look at this reaction of 2-methyl buta 1,3 diene with ozone in zinc water gives a product like this. Tell me what is that? Buta 1,3 diene. So this is but 1,3 diene 2-methyl with ozone, okay, zinc and H2O. What will be the product form? Tell me what I am saying. So just break this. Ozonolysis means what I told you, just break these double bonds, wherever double bond is there, break the double bonds and try to insert oxygen on it. So CH2 double bond O. So this side will be one CH2 double bond O, here also one CH2 double bond O. So it means 2 moles of formaldehydes are formed. And what about the other one? So 1, 2, 3 carbons are there. So write that 3 carbons here, one methyl group attached to double bond O here, and this side CH3 like this. So that will be the product. So that is nothing but, look at the options, where do we have that kind? See, CH3 CO CHO. See, CH3 CO CHO. Yes, this is what we got. And 2 formaldehydes. Yes, 2 formaldehydes. So option B will be your answer for the question. Okay, right now is this clear or not? Yes, if it is clear, just click on the like button. Yes, and you can mention in the chat box. If you have any confusion, please mention in the chat box. You can write in the chat. Yes, you can feel free to express your concerns in the chat. Right. And after this, I will be giving you one question for your practice purpose, and tell me your answer for this. So what is the IUPAC name of this product B formed during this process? So this alkene, upon treating with ozone in zinc and water, it gives B. What is the IUPAC name of this B? Tell me your answer for this particular question in the chat box. I will be looking into it. Okay, right. Next, can you answer me this? Correct order of rate of acid mediated dehydration from the following compounds. So which one will be more easily dehydrated? Which alcohol will be more easily dehydrated? By adding H plus ion. By adding H plus ion. If you add H plus ion, it should remove water from here right now. So where it is possible? Very easily. So it means when we add this H plus ion to this water, so it will comes out, OH groups comes out as a H2O and generate a positive charge on this tertiary carbon right now. So here also positive, here also positive, here also positive, here also positive you are going to get. But which is more stable carbocation here? So this is a tertiary carbocation now. So tertiary carbocations are more stable when we compare with the others. So it means this will be formed easily because tertiary carbocation forming as a intermediate will be more stable compared to other. Therefore I can say this will be more reactive during this dehydration of alcohols in acid mediated reactions. So 3 is more reactive. After 3, here you are going to get a primary, and between these you are going to get primary here, and here you are going to get a secondary. See, if this is a primary which is very least stable because it is N-butyl. N-butyl means, so 1 will be least here, 3 1, say 3 1 here and here, okay. And after this we have these 2 now. See, if I remove this water from here, you are going to get a positive charge here, but this proton will be rearranged to that and generates a stable carbocation in C, because tertiary carbocation is formed by rearrangement. So 3 2 4 1 will be your answer. Option C is your answer for the question. Okay, right. Discussion is clear. And tell me this one last question on ozonolysis reaction. How many times it is repeated? See, just see the question, how many times it is repeated. So what they are saying, propane to one, see an alkene X, okay, an alkene X upon ozonolysis gives a mixture of propane to one, okay, propane to one and methanol, formaldehyde is produced. So what is that X? So just simple, ozonolysis means nothing but breaking of double bond and inserting oxygens now. So just remove these oxygens and go back to give your alkene. So this is this part. Now combine this carbon with this carbon. So this one like this. That's it. This is your answer for the question, because if you break here double bond and insert oxygens, you are going to get this one and formaldehyde right now. So it means what is the name of this compound? 1 2 3. So this is nothing but 2-methyl propene. So 2-methyl propene is your option B for this particular question. Hope whatever we discussed till now are clear. So the things that are required from alkene chapter is almost covered here. All the important reactions which are required for your upcoming EAPCET are covered here, and PYQs are also discussed. So if you still have any confusions regarding this, you just mention in the chat box, that we will be covering in the upcoming sessions, okay. And in the next session we will be covering complete alkynes chapter along with the PYQs of EAPCET or NEET JEE questions, okay. So no worries, if you have any concerns, write in the chat box, we will be discussing them in the upcoming